about the vectors?
Sir, about vectors.
Yeah. Okay, I'm just confirming that from where should I start? Okay. So if you will say, I can start from the first chapter also, from the vector or from the vectors also I can start, because I will tell you that when you will study the 11th physics, so what will happen? There is a requirement of vector. You should have a deep understanding of vectors, because you have also seen, if you have an idea of that uh, laws of motion and all that, there is a requirement of component and direction and force and all that. So vector is important chapter, and so should I start from the vector? Actually, vector is a basic thing, and after the vector we will start kinematics, or you can say motion in a straight line. So what do you want? What should I do?
Okay, sir, vectors.
Fine now.
Yes, sir.
Okay, just I am giving you the brief introduction of, if you want, if sometime if you feel that you want to change the chapter, means if you want to read the work, power, energy and Newton's laws of motion, then you can tell me, I will change that, okay, accordingly. Okay, fine.
Yes, sir.
Okay, so just we are you are in 11th, so 11th is the starting of just the physics, I will say. In 9th and 10th is very very basic, and here when you are in 11th, you will see the things uh, more closely. You will observe the things more closely. Okay, so uh, actually, what is physics? First, I will tell you. Physics is something like we observe the natural phenomena, and with the help of mathematics we describe those natural phenomena. Okay, and basically in simple words, if you will say, physics is the study of natural phenomena. Okay? So
Okay, sir.
yeah, for studying these natural phenomena, scientists uh, discovered many things, and they found that there are some quantities, like there are some quantities like mass. I'm this time I am just talking to you generally. I am not teaching the physics. So like mass, like length, like time. What is time? What is mass? What is length? And all these things. And you have also uh, you already know what is speed. I think uh, what is acceleration, what is distance, and what is displacement. These are some quantities in physics that we will use. Force we will use. Work we will use. Okay. So for the simplification, for the simplification, the quantities in physics are described in two categories. Okay, just giving you the basic idea of the vectors. So in physics, when we will study physics, vectors and scalars. Okay, so there are two types of quantities. Uh, means those quantities which are measurable. Measurable things are known as quantities, like force is a quantity, speed, and length, mass. These are the quantities, and these quantities are of two types. One is scalar, one is vector. So scalars, first I will define scalars. What is scalar quantities? This is very basic lecture. So scalar quantities are those quantities that can be defined only with magnitude. Okay, these quantities have only magnitude. I will give you the example also. Magnitude, what is the meaning of the magnitude? Magnitude is the numerical value. Like I am saying 5 centimeter length. So 5 is the magnitude, the numerical value. Okay. So example of these scalar quantities: distance, distance. So suppose you have traveled 5 kilometer. Okay, 5 kilometer distance. So that 5 kilometer, 5 kilometer is the magnitude of distance. Okay, speed. Suppose you are driving a car with a speed of 100 kilometer per hour. So the speed also a scalar quantity. Okay.
Yes, sir.
Yeah. And there are many quantities that we will discuss. Work also is a scalar quantity, and heat. These things you will get. This distance and the speed we will study in the next chapter or in the coming topic. But work and heat you will get in work. You will get in work power energy chapter after the Newton's law of motion. Heat you will get in thermodynamics and all that. So these are some examples of the scalar quantities. So now, what are vector quantities? In simple words, the vector quantities are the quantities having magnitude as well as direction. Having magnitude as well as direction. So see, so you can write these quantities have. So you can write these quantities have magnitude. When I will give you the example, it will this thing will be clear. The quantities have magnitude as well as direction. And follow the vector laws. This statement, follow the vector laws, I will tell you later, but this thing I am telling, these quantities have magnitude as well as direction. So for that, with the help of example, I will explain. Okay. Suppose you are in a car and you are driving that car with the speed of 10 kilometer per hour, or you can say 50 kilometer per hour. And if you are in a car These are the directions that we show on the paper. So if you are going in this direction, means you are going towards east. If you are going in this direction, so if you will go, this is the north direction, this is the west direction, and this is the south direction. So suppose you are here and you are in a car, or you are on a bike or a car, you can say, suppose, and you are moving in this direction with a speed of 50 km/h. So this time direction is involved. This time direction is also involved. So speed with direction is known as velocity, and that velocity is the vector quantity. Okay, velocity. What is velocity? Speed with the direction. Now there is one more thing. Suppose you are moving, this is the east direction. Suppose you are moving from this point A to point B, point A to point B. Okay, and suppose you have covered a distance of 1 km. You are here initially and you are moving in this direction. Suppose you are walking in this direction and you have covered a distance of a straight line distance of 1 km. So this time you have covered a distance of 1 km in each direction. Here also the direction is involved. So this distance with direction is also known as displacement, and we will discuss this displacement in detail in the chapter motion in a straight line. So displacement. Okay. So speed, displacement, and when you will study further, then you will get there is a term acceleration and force. So what about the force? Force always comes with direction only. Suppose this is a block and this block is on some surface. Suppose this is a surface and this is some block. And if you want to move this block from this position to this position, from this position A to position B, so what you will do? You will apply the force now in a particular direction. In a particular direction means you will not apply the force in this direction. If you will apply the force in this direction, this block will move in this direction. Okay. So what you will do? You will apply a force like this. So this block should be moved in this direction. So simply I can say you will apply a force like this. So that is why this force is also a vector quantity. Force is also involved with direction. So there are many examples of vectors. Okay. Now,
Sir,
yeah.
sir, why work is scalar?
Why work is scalar? Because, do you know what is work? See here. Actually, work is force. This is the thing that you will study in work power energy. This is actually vector product of force into displacement. Okay, and when you will open it, you will get Fs cos theta. Okay, and why the work is scalar? One thing is that work is never involved with direction. Okay, you are doing a work of, suppose you are doing a work of here is the here is the block, okay, and you are applying a force on this block like this, and this block is moving from here to here, okay. Suppose this is a block here, you have applied a force and this block moves our displacement s. So work this time will be force into s, okay, force into s. So this work is not related with direction, means you are just supplying the energy. What is happening here, you can see this force will be applied by some person, this force will be applied by some person, and this person have the energy, okay, this person have the energy, and due to this energy this force is coming out, okay, and due to this force this work is done. So means energy and work are related, means due to this energy you are getting the work, and there is no direction of energy, okay, fine. Or simply you can say work is not a scalar, work is not a vector, because we can define work with the help of only magnitude. There is no requirement of direction. And here also you can, from the formula also, if you will apply the formula of work, work is a dot product of force into displacement. So when you will do the dot product, always you will get a scalar quantity, okay. When you will, so just I am taking one more example. Suppose 5 I cap, if you are doing the dot product of 5 I cap and 3 I cap, if you know the vectors then you can get it. So you will get this 5 3s are 15 and I cap is 1, you will get this 15. So this 15 is a scalar only, this is only a numerical value you will get, okay. So from here also you can define that, because work is a scalar product of force into displacement, that is why work is a scalar. Or work is related with energy, so energy has no direction, work has no direction, okay. Got it or not?
Yes, sir.
So now we will discuss the representation of vector, how the vectors are represented. Representation of vectors. So have you got it? Why work is not a scalar? Why work is not vector?
Yes, sir.
Why? Tell me.
Sir, because it is derived from energy which can be given through the magnitude only, and
Mhm.
because it is the dot product of force and displacement which gives a scalar result.
Very nice. Fine. Actually, this is not the. Actually, we are discussing the initial stage, and this question is from somewhere. When we will discuss the work, power, energy, and all that, you will get all the answers clear. Okay, I have to teach you here that what is a scalar product and what is vector product and all that. But do you know what is a scalar product and vector product? Means, do you know this A cross B and A dot B? I'm just taking the idea.
No, sir.
Okay, beta. Then how can you understand that this f dot s? This is the dot product or the scalar product, and this is given by fs cos theta, and this value is the scalar only. Okay, okay, no problem. Fine. So representation of vector, how we will represent the vectors? There is a simple representation of vector like this. What you will do, you will take an arrow. This is an arrow, and this arrow, this this is the tail of arrow. This is the head of the arrow. Okay, and this arrow has some direction. This arrow has some direction now.
Yes, sir.
Suppose I made the arrow like this. I made the arrow like this. So you can identify this arrow and this arrow have different direction. Means this arrow has different direction. This arrow has different direction. Okay. So if the length of this arrow is suppose a, okay, if the length of this arrow is a, then this arrow is the representation of a vector. A vector is written as a, and this arrow on a. This is known as a vector. So if you will write the representation of the vector, then you will represent the vector with the help of arrow, because vectors have two things. One thing is magnitude, other thing is direction. So if you will talk about the magnitude, so magnitude will be the length of this arrow, that is a, okay, or this is sometimes represented by this, okay, mod of a vector. And direction you can get from the arrow, direction of the arrow, okay. So direction you can get from arrow. So in this direction, this is the direction. Okay. So representation of vector means I am representing a vector, a vector. This term is, this symbol is called as a vector. Okay. Fine. And magnitude of the vector is, you either you can write a or mod of a. So now there are different types of vectors. Okay, there are different types of vectors. Types of vectors. Okay. So unit vector. First is unit vector. Now you can imagine that you are in the world of vector. Okay. So what is unit vector? Unit means one. Unit means one. So unit vector is a vector having the magnitude 1. Okay. A vector of magnitude 1. A vector of magnitude 1. And this unit vector is represented by, suppose I am writing this as this a cap. So this unit vector, for the unit vector of a, you will write a and you will give it a cap, a cap. So this is unit vector of a, you will write. This is unit vector of a vector. And what is the magnitude of this unit vector, and how we will represent the magnitude? This way. Means if you will calculate the magnitude of this will become 1. Okay. This is unit vector. Now,
Sir, what will be the example?
what will be the example? Okay. Suppose you have a vector, a vector, 5. Are you comfortable with this? Can I write the vectors like this? If you are comfortable, then I can write. Means unit vector, for the definition of the unit vector. This is just the introduction, okay? And for this, I have to do something else. Just I am trying 5i and 4j. This a vector is given. Suppose a vector is given as this 5i cap plus 4j cap. So if you want to calculate the unit vector of a vector, okay, so what you will do, you will write this like this. You will write a vector divided by magnitude of a vector. So what is a vector? A vector is this. You will write here 5i plus 4j, okay, and you will calculate the magnitude of this vector a, okay. So how you will calculate the magnitude of this vector? Do you know about this? Do you have any idea?
No, sir.
That is why I am not telling. Okay, no problem. If you want to calculate the magnitude of this a vector, na, so just take the under root and do the square of this plus do the square of this. Square of 5 plus square of 4. So what is the square of 5? 25. What is the square of this 4? 16. So what is the answer? 41. So now you can put the value and you will get the a vector. A vector you can get, you can put the value here, this root 41. So this a vector is the unit vector.
Sir, so final value will be equal to 1.
Of course, the final value will be equal to 1. If you will take the magnitude of this, just take the magnitude. You will see that the final value will be 1. Okay, just let me explain. Okay, now if you want to find the magnitude of this, na, if you want to find the magnitude of this, so what you will do? You have this value 1 upon root 41. Now you will just calculate the magnitude of this 5y plus 5j. If you want to find the magnitude, then you will write this in the modulus form. And how I have find it out the magnitude of this? No, this is not 5. This is 4, no? Here is 4. Here is 4. Here is 4. So again you will get the root 47. This is 5 square plus 4 square. Again you will get 25 plus 16. You will get this as root 41. This is 41. Okay. When you will divide 41 with 41, what is the answer you will get?
1.
Yeah. This value is 41 now. Magnitude
Yes,
of
sir.
this is root 41. This is root 41 and this is root 41. You will get the answer 1. Okay. So these are the things that we will going to discuss later. That is why I was not giving some example. And if you are saying that the example, this is very simple. Suppose you are moving with a velocity of 1 meter per second. If you are moving with a velocity of 1 meter per second, so your velocity is 1 in x direction. This is I cap. So this is the example of unit vector. Okay. And this thing I have to tell. That is why I am not giving the example. I was not giving the example.
Okay, sir.
Means if you want the example, then what you should say, if someone is asking, just give the example. And if you do not know about this universal unit vectors, okay, if you do not know about this universal unit vectors, so you will say simply a vector of magnitude 1. A vector of magnitude 1 mean you can say velocity. If the velocity having the magnitude 1, then this velocity vector will be the unit vector, in simple words. Or if you want to define it properly, then you should know what is I cap and j cap and how you will calculate the magnitude of the vector. Okay. Okay, fine. Just now, coming to the collinear vectors, you have completed the Newton laws of motion in your school.
Yes, sir.
Okay. So unit, this is all about the unit vectors. Okay, now I am taking another example, means another type of vector, collinear vectors. Collinear vectors. Collinear vectors means, in simple words, if you will say, these collinear vectors are parallel vectors. Suppose the vector is like this. Suppose the vector is like, one vector is like this, and another vector is like this. Okay. They have the same direction now. They are going
Yes.
in the same, they are parallel vectors.
Yes, sir.
Okay. Collinear vectors are parallel vectors as well as anti-parallel vectors. First is parallel vector. And can you tell me the which, suppose this is the A vector and suppose this is the B vector. Can you tell me the magnitude of A vector is greater or magnitude of B vector is greater?
B vector.
Why?
It's greater in length.
Yeah, very good. Fine. Because, but they are parallel vectors. So that is why they are collinear vectors. Okay. So collinear vectors, you can also say that if the vectors are like this, if two vectors are like this, suppose one vector is like this and another vector is like this, means one vector is like this and another vector is like this. Suppose this is a vector and this is a V vector. So you will say A vector and V vector are collinear vector, or this time these type of vectors are anti-parallel vectors. If the vectors are parallel in same direction, they will called as parallel vector. If the vectors are parallel in opposite direction, then you will call anti-parallel vectors. Anti-parallel vectors. Just so this is about collinear vectors, unit vector, collinear vector, and now third is equal vector. From the name you can get what is equal vector, what are equal vector. if two vectors are like this, suppose if one vector is this and another vector is this, suppose this is A vector and this is B vector. So when you will observe these two vectors, these are equal vectors. Why these are equal vectors? Because the length of the vector, length of this arrow means the magnitude as well as direction of both the vectors is same. Okay, equal vector means you can write magnitude as well as direction of vectors are same. Getting?
Yes, sir.
Do you have any doubt?
No, sir.
Means here from here. You are the first student that asked me any doubt, and I will appreciate that. Okay. And one more example I am taking. This will be used. That is why I am taking for solving the numerical. There are vectors named as co-initial vectors. Co-initial vectors. Co-initial vectors are the vectors starting from the same point. Starting from the same point. This is the point. Suppose this is the point and I am taking two vectors. One vector is this, another vector is this. Irrespective of the direction or the magnitude. Okay. Suppose this A vector, this is A vector and this is B vector. And these both the vectors are starting from the same point. So A vector and B vector will be co-initial vector. So you can write vectors starting from the same starting point, or you can say not the same starting point, the same point, the same point. You can see these two vectors are starting from the same point. That is why now if you want to define the position in terms of vector, then there is a vector for that known as position vector. So this I will tell you with the help of example. And I can give the example of this also, example of this also, example of this also. But when we will solve the numerical, you will get it automatically. Example of this, what are the example of two equal vectors? Suppose you have a force acting in this direction. Suppose 5 Newton force acting is in this direction and 5 Newton force is acting in this direction. For Newton is a name of the scientist as well as the unit of force. So 5 Newton force is acting in this direction and 5 Newton force acting in this direction. So these two vectors of forces are equal vector. Okay.
Yes, sir.
Example, if you want to take the example of this, then you can say that suppose someone is applying a force of 3 Newton in this direction from this point, and someone is applying a force of 5 Newton in this direction. So this is these both are the example of co-initial vector, and we will solve what is the resultant of that when we will study the addition of vector. So position vector, position means, what is the meaning of position? Position is, suppose I am here, you are there, and this pen is here. There is a specific position of something. Okay, location you can say. Suppose a point uh, what happened?
Sir, I got disconnected.
Okay, no problem. So I am telling you the position vector. Okay, the position vector means if you are defining the position with the help of vector. So see how you will do. Suppose here is a point. Here is a point. Suppose you are here at this point. There is a specific position of yours, and this point I will say is A point. And when we say the position, we will always include the reference point. Means suppose you are in a school, you are in a school. So what you will say? I am 5 kilometer far from my school. Like suppose that with the help of example. Suppose this is you, and this is you are in a school. So for defining your location or for defining your position, there is a reference point. Okay. So reference point, suppose this is your home. So you will say that I am 5 kilometer far from my home. Okay. So you will take home as your reference. Okay. Or if you are not living in your home, then you can take hostel as your reference point. Okay. Reference point can change accordingly. Okay. So now suppose you are at this position A, and for defining the position you should require a reference point, and this reference point is origin. And if you will join this origin to your location and make it a vector, and if you will measure the length of this, suppose you are at a distance of uh, this point A is at a distance of 5 meter. So the magnitude of this, suppose this point is O, magnitude of this OA vector is 5. Okay. So this OA vector is the position vector of A. Of A, of point A you can say.
Yes, sir.
So these are just the tools. These are just the mathematical tools that you will use to solve the questions. Okay.
Yes, sir.
So Divangi, what is your name? Please tell me again. Divanshi,
Devangi.
Devangi. Oh, okay, Devangi. Devangi, do you know what is force? What is force? I mean, how you will define the force? Okay.
Mass into acceleration.
Hmm, this is the formula of force, mass into acceleration. And I can, if I will say there are many formulas of forces, like force is equal to charge into electric field in 12th class, then you will go. Then the definition of the force will change again. Force means simply you can say if you are just pushing or pulling something. Suppose this is a mouse now, and I am just applying a force means I am pulling it or pushing it. So push or pull in simple words, if you will say, is force. Okay.
Yes, sir.
And uh, what is the displacement? Do you know displacement? Means we have to study, I think, from the starting. Okay.
Displacement is the shortest possible distance between any 2 points in a straight line.
Yeah. Right. And velocity, I have told you. Acceleration, do you know?
Change in velocity per unit time.
Very good. Means you know the things. So are you fine with this chapter, or from the next class, if there will be a next class, so you can tell me which chapter you want to study. Means this is the trial class now.
Will vectors be used in work energy and
Of course, uh, means you should know the vectors. If you do not know the addition of the vectors, subtraction of the vectors, if two vectors are at angle, how to calculate the resultant, you can study anything, but you will not understand that. This is my opinion. Means
okay, sir, then we can do vectors.
yeah. And when your exam will be conducted?
28th September.
28th September. So what are the chapters that are coming in the examination?
2 to 6.
2 to 6. 2 to 6 means okay, means uh, okay,
Units and measurements, motion in a straight line, motion in a plane, laws of motion, and work, power, and energy.
so can you tell me what is Newton's second law of motion? Newton's second law of motion. I will tell you, but I'm just asking whether you know or not.
Sir, I think that its force is the product of mass and acceleration.
Hmm. Okay, okay, fine. So position vector, okay, and there is one more vector, displacement vector. Displacement vector. Displacement vector. Suppose you are moving from here to here, okay, and the initial point of yours is A and final point of yours is B. So suppose you have traveled some distance also, AB have some length also, and you are moving in the direction of AB. So this AB vector this time will be the displacement vector. Displacement vector. And now there are very important things that I will discuss, and after that, if we will have next class, then we will meet in the next class. Orthogonal unit vector,
So,
or you, yeah.
what's the difference between displacement vector and position vector?
Oh, okay. See here, suppose you are here. What I have told you, suppose you are here, okay. This is
Yes,
the
sir.
first condition. This is the first condition. And suppose you are moving from here to here, okay. If you are here and we are defining the vector, okay. If if you are here, this is your position right now.
Yes, sir.
Here you have only one position.
Yes, sir.
Now I am saying that in this case, in the second case, you are moving from here to here. You have many positions. You will be here sometimes. You will be here sometimes. Suppose you are moving in this direction and you will be here. And you will be here. Okay. Whenever a single point is to be defined, whenever a single point is to be defined, then we say we will use position vector. So position vector is always defined with respect to origin or a reference point. Okay. So this vector will be the position vector. When there is only one position specified, then you can say this OA vector. Suppose you are at A, this OA vector is the position vector. Suppose the distance is R. So this OA vector or R vector is the position vector. And whenever you are moving, means whenever you are displacing, okay, whenever you are displacing or you are moving, then you will define the vector. Then for that motion or for that displacement, if you want to define the vector, suppose you are at here at A and finally you are at B. So if you are meeting these 2 points, then this AB vector, in simple words, you will say, if you already know the reference point from where you are coming, means this time you are coming from A to B, okay, you already know you are coming from A to B, then you will write AB vector as a displacement vector. But you are already at A, but you do not know from where you are coming. So if you do not know from where you are coming, means you are coming from origin. And if a vector is defined with respect to origin, then it is the position vector. And if a vector is defined with respect to some given position that we already know is the displacement.
Okay, sir.
So now tell me, what is the difference? Okay, fine. The difference is whenever a reference point is given, okay, whenever a reference point is given, suppose here a reference point is given, means you already know that you are coming from A to B, means In simple words, you will say whenever you are moving from one point to another point, and you will write the vector of that, then you will say that vector will be a displacement vector. And whenever you are already at a location, okay, then you will write the position of this vector with respect to origin. Then you will say it is a position vector, and this is a displacement vector. Very good. Okay, anything else you want to ask in this? Any question?
No, sir.
So, all things are clear here. And
Yes, sir.
if we will have the next class, then we will discuss the orthogonal unit vectors, and after that, parallelogram law of vector. Have you heard about the parallelogram law of vector? Means you
Yes,
have
sir.
just